looking at sampling distributions and within them finding the population proportion, standard deviation, expected numbers, and standard error. All right, our example says the proportion of adult women in a certain geographical region is approximately 53%. A marketing survey telephones 450 people at random. All right, so our first question says, what proportion of the sample of 450 would you expect to be women? Well, with this quick problem, we're looking at the assumptions that the sample values are independent and the sample size is surely large enough. So therefore, the sampling distribution, right, of the p hat, that's going to be modeled by the normal model with the mean of p hat. So it's going to be equal to p, which is the population proportion. So the population proportion for us here is just going to be 0.53, that 53%. All right, so the next question says, what would the standard deviation of the sampling distribution be? Standard deviation of the sampling distribution. So again, since the assumptions are already that the values are independent and the sample size is large enough, then the sampling distribution of p hat is modeled by a normal model, as we stated, and it has a standard deviation. I'll write this out. Standard deviation equal to the square root of pq over n. All right, so p is the proportion of successes, q is the proportion of failures, n is the sample size. Okay, so to find that q, we would just say, okay, what's the complement of p? So 1 minus p, so that'll be 1 minus 0.53. Then that gets us 0.47. All right, so the sample size is 450 women. So our n is 450. So now we can find the standard deviation, and what we should do is probably go ahead and show that. So again, the standard deviation is going to be 0.53 times 0.47. That's all divided by the 450. So now you just use your handy dandy calculator, crunch the numbers, and maybe rounding to 3 decimal places, you'll get 0.024. Okay, and then let's take a look at that last question. It says, how many women on average would you expect to find in a sample of that size? So let's take a look at that. So to find the expected number of women in the sample, we're just going to multiply the population proportion by the sample size. So multiply the population proportion by the sample size. Okay, so all that would be for us is the 0.53 times 450, and then that gets us 239. So we would expect to find 239 women in a sample of 450. Let's look at our next example. A research company polled a random sample of 111 teens about internet use. So 46% of those teens reported going online several times a day, and this is a fact of great interest to the advertisers. So we're going to explain the meaning of p hat equaling 0.46 in the context of this situation, and then we're going to just go ahead and do a quick calculation of the standard error of p hat. So with this, the sample proportion p hat is the proportion of outcomes in a sample that are a certain value. So in this case, the value of p hat indicates that 46% of the 1,111 teens in the sample said they go online several times a day. So the sample proportion of p hat, right, this is for us, this is the best estimate. It's the best estimate of the population proportion. The best estimate of our population proportion. So now we're going to use that information to go ahead and calculate the standard error of p hat. So for the sample proportion p hat, the standard error, we calculate that with the following formula. So it'll be the square root of p hat times q hat over n. And of course, q hat is going to be the complement of p hat, which is 1 minus p. N is the sample size. So we've identified the sample size, N is 1,111. And then we'll calculate that q hat. So remember, q hat is going to be 1 minus p hat. So we'll substitute 0.46 for the p hat. So 1 minus that, and then that will leave us with 0.54. Okay, so with that information, we can go ahead and plug into this formula. So we'll have the square root of 0.46, and that's going to be multiplied times 0.54. Okay. And then that's all divided by our n value of 1,111. Okay, and then we get, by crunching the numbers in the calculator, 0.015. So the standard deviation of the sampling distribution of the proportions is equal to the square root of PQ over N, right? That would be the formula that we would use. But because the population proportion P is unknown within our problem, then the sample proportion P hat and its standard error has to be used to estimate the standard deviation of the sampling distribution.